and it's commonly known as azotic indica. It has different properties like antibacterial properties. It contains a lot of benefits towards health, towards different natures of life. And I have converted it into biochar to enhance its properties. And for that, I have converted into biochar with the with the process of pyrolysis, and uses in absorption of the removal for the contaminants. If we have a contamination, I'm working on fluoride contamination, so it should have sources. So the possible sources of fluoride contamination is mainly the volcanic eruptions that is the main cause of fluoride contamination, because it caused the mineralization of fluoride, and that leached into the water, surface water especially, and it converts, it just leached out the fluoride in the drinking water. And other thing is industrial emulsions, like when industries effluent is being throw out to the or run off into the water, that highly contaminates the water with different chemicals such as fluoride, arsenic, many others. Fertilizers are also reaching the groundwater as well as in surface water, and also the precipitation that goes on can also increase the fluoride concentration in surface water. The problem: fluoride is very essential for human health because it's a very required mineral, but it could be toxic if it's in high quantity, more than 1.5 mg per liter. It could cause different defects that contains like the developmental defects, dental fluorosis, skeletal fluorosis, bone cancer, reproductive defects, neurobehavioral defects, mutagenicity, hypothyroidism, and kidney stones. These are the extreme effects if fluoride concentration is higher than 1.5, or maybe much more higher than that. Then fluoride removal. If there is a problem, then there should be a solution. For fluoride removal methods, mainly membrane process is used, but it causes biofilming. That is a very great drawback of membrane process. Coming towards ion exchange process. Ion exchange process is a very effective process, but it requires a lot of energy. Electrocoagulation, again, it's a very effective process, but it also requires a lot of energy, and coagulation causes sludge, and that is a very mean problem to we handle it. Then coagulation and percolation, again, it requires chemical, and it gives a lot of sludge that is very difficult to handle. Absorption is the most promising and most sustainable method because of its ability and low cost approach. So I have used neem seed for the absorption purpose, and I've converted it into neem seed biochar that look like this. Research objectives. My first objective was to synthesize and characterize neem seed biochar, and then to use it for the absorption purpose and treat it with perchloride. These are my literature view. I have considered different literature views uh, regarding fluoride concentrations in different districts of Pakistan, and then coming towards the health effects of like fluoride, adverse health effects of fluoride, and then the removal with the neem, either its leaf or its stem, and as neem is used in different form of for the removal, and also it also help like different contaminants also being used for this option. Now coming towards my methodology. Firstly, I have converted my methodology into three parts. First was the absorbent preparation. For absorbent preparation, I have used neem seed to prepare neem seed biochar and activate it. For that, I have collected neem seeds, I have washed them, I have dried them, and then pyrolysis. Pyrolysis is basically the burning or a process that converted biochar into a charcoal form. For that, I have used a oven, and for that process, I have taken temperature of 350 degrees Celsius, and I have converted in I have it took almost 3.5 hours, and that is slow pyrolysis. I've used nitrogen purging so that it could not catch fire. And in the end, when I just measured the weight, it was 70% weight reduction in overall amount of neem seeds that I've used. Then I have gone through the crushing process. That was 1 mm to 0.5 mm. I've selected this size between the for the crushing method. Then I've activated or impregnated it with the FeCl3 to enhance its property. And for that, I have used 4.8 grams of FeCl3, 5 grams of biochar, and 100 ml of DI water. I have washed and dried it, and then drained and dried it. I've agitated it for almost 200 rpm for 24 hours. I've gone through characterization. For that, I have used a spectrophotometer for the detection of fluoride, that how much amount of fluoride is being remaining or it's being used. Then scanning electron microscope to find out the morphology of biochars. Energy dispersive X-ray, that is EDX, for knowing up the elemental percentage of any elements that will be present in biochar and treated biochar. Then for frontier transform infrared spectroscopy, that is FTIR, it is basically used to know the functional group attached to the biochar or treated biochar. Going towards batch absorption study, that is my third part. I have firstly selected the 4 parameters, that is mainly the absorption parameters. I have kept one variate and other 3 constant. For the first part, I have varied time between 15 minutes to 150 minutes, and kept constant like pH. I have kept constant to 7, initial concentration to 0.5 ppm, and absorbent dose to 800 mg. Then I have made a constant pH 7, initial concentration 0.5 ppm, and equilibrium time 60 minutes, and varied absorbent dose to 200 mg to 1 gram. Then initial concentration I have varied from 0.2 ppm to 1 ppm, and make pH 7 as constant, and absorbent dose 1 gram as constant, equilibrium time 60 minutes as constant. And last but not least, I have varied pH from 2 to 10, absorbent dose 1 gram, initial concentration 0.5 ppm, and equilibrium time 60 minutes. Isotherm studies. I have studied furthermore the 2 different studies, isotherm and thermal. For isotherm studies, I've used the French isotherm, and like mere models for knowing out the efficiency or the better removal of my fluoride.
Naza, you have 2 minutes to conclude.
Okay. Kinetic studies, pseudo first order, pseudo second order, these are their respective equation. Standard curve was used R square with a value of 0.99. This is the FTIR that shows different functional groups that are being attached. This is FTI of treated biochar that shows only the carboxyl group uh, within the difference. These are the 2 images of SAM. First shows the biochar, and the other one is treated biochar. As you can see, treated biochar has the white spot that shows the presence of FeCl3. EDX, this shows the FeCl3. Uh, uh, it does not have the presence of FeCl3, and the other has the FeCl3 concentration higher. Effective amount usage. These are my basic results. I have used as 200 to 1000, and the 1000 like 1 gram was the highest, gives the highest percentage removal, and again 60 minutes it get the equilibrium condition. For initial concentration, 0.2 ppm shows the highest removal, and again in 60 minutes it got the equilibrium condition. For pH, 6 to 8 pH shows the highest removal. Isotherm model from isotherm model Fenrich follows the maximum. As you can see in the parameter, R square value is 0.9235. That is the maximum value that could reach. And Fenrich was the one who follows the my study. Then for kinetics, to the second order follows my studies. That is 0.9981 R square value. Concluding, highest removal, as I told you, that 95% of reach between pH 6 to 8, 2 mg per liter was the initial concentration, that was the maximum touched. Absorbent dose was 1 gram, and 1 hour take to achieve at equilibrium condition. French was followed, so the second order was followed. STEM condition shows the morphology, EDX shows different elements, FTI shows the functional groups. Recommendations could be a column study can be done afterwards. Material based study could be conducted. Biochar activation method could be used. Different biochar methods. Waste product can be used as a bioadsorbent. filtration system can be done, and education to the filtration system can be made. These are my references. Thank you.
Thank you so much, Unaza, for a very excellent presentation. And now I invite Mr. Mehtab Ahmad for his presentation on fabrication of low-cost soil moisture sensor with calibration algorithms for smart irrigation. Over to Mehtab Saab.
Hello everyone, I am Mehtab Ahmed and from Hydraulic Irrigation and Drainage Department of USPCAS W Meran Ministry of Engineering and Technology Jamshoro, and I am going to present my topic on fabrication of low cost soil moisture sensor with calibration algorithm for smart irrigation system. And these are my table of contents. So introduction. The world population is increasing rapidly and growing population demand more resources which increases the burden on water resources. Plenty of water is required in agriculture field for the production of food. So the agriculture is an important sector for our economy to constant monitoring and required to optimize our yield. So IoT, the Internet of Things system irrigation water management is very helpful because irrigation requirement is 90% of our total use of fresh water, and from 50% of that is wasted due to poor irrigation system. So in a literature review, there are finding that the smart technologies like sensing technologies, which soil moisture sensor, are very helpful to get high integrative data from 92 to 99%, which mean there is a very low data loss. So we can use these technologies for our betterment. The calibrated soil moisture sensor can be used instead of high cost sensor by using suitable calibration algorithm, and error tolerance should be up to 3%. The soil moisture sensor technology can betterly manage the irrigation by reducing 15 to 94% of water and increasing 15 to 50% of crop production. So for this study, I have divided my methodology into three phases. One is to fabricate the sensor. For that, we find the sources for component, select suitable component by testing for power and other electronic tests, and then design the best assembling arrangement so we can optimize our power usage, our results, and finally fabricate the sensor and test it on the field. In the phase 2, we took soil samples, soil tests, and then generate calibration equation for different soil types, and then develop a decision support system. In phase 3, after the calibration, we again test soil for our census results and compare with the gravimetric oven dry method, so we can conclude that our sensor is accurate or not. And finally, we develop a prototype. So in the first of result, we took five different board which is readily available in the market and testing for power, voltage, digital output, analog output, and controllers. So finally, we concluded that Arduino Nano is power consumption of 19 milliamperes, and its life is 12,000 hours, which is given by our manufacturers. So, basis of this result, we took Arduino Nano for our sensor fabrication, and uh, in take in consideration, we design it on a visiting electronic software which give us these results. Well, in this, there are two module, which one of is Wi-Fi enabled product which can be used in remote area with the help of Wi-Fi, and another is LED indication based product which can be used by the unaware farmers which are not aware from soil moisture, but they can see the LED lights and guess the moisture in the soil. So after a fabrication, we install some sensors on the field. So these are the results from after installation of 15 days. Initially the moisture is gradually increase because the inlet point is far away from the sensor. But in the second term, we put the inlet in front of a sensor, so we can see that how the top, middle, and bottom soils are saturating and unsaturating by the time. After that, we calibrate our sensor with 4 different soils. Our soil is capacitive soils moisture sensor, which is working on capacitance base. And due to increase in water in the soil, the capacitance of sensor is decreasing gradually. So we put the gravimetric moisture content with capacitance and formulate them some equations for river sand and for garden soil and for agriculture land and orchard land. So by these four group of soils, we get the data, and finally we optimize the data and combinedly make a question for whole soil, which we assume that it will work on all soil. And the equation will found is y is equal to 1045.7 exponential power minus 0.014 into capacitance of the sensor. After that, we develop a decision support system. The working of decision support system is like the loop. It start and check the soil moisture sensor and temperature and humidity, and then check if the threshold value and fuzzy logic algorithm is applied or not. If yes, then it turn on the pump. If not, it turn off the pump, and then loop start. If yes, then again it check the moisture and temperature humidity. If yes, then it's ongoing the process of loop. So it will help to reduce water usage, and it will increase the crop yield. After the calibration, we want to validate our sensor that our sensor data is accurate or not. So we took the sensor to the field and get some samples, and then plotted the scattered graph. So here are the scattered graph, and red line is 1:1 line. It means the linear line of the data is nearly to the 1:1 line. That means it is really accurate at the assumption, and the correlation is found 0.9976. And for the lab testing, we also conclude the lab test, and we found that the R square value is 0.9882. And after that, we check the sensor for data integrity and mean absolute percent error. That mean our sensor gave us 94.45% data integrity and 0.92% mean absolute percent error. And in some paper they are shown that if result is MAPE is less than one and data integrity has greater than 90, so we can use that technology for in research and in management. So after that validation, we design a
Mehtab, you have
cases
one
for.
minute to conclude.
Okay.
You have 1 minute to
So
conclude.
we have cases. So we have a cases for the sensors, and we also develop a dashboard on things speak user friendly software, so we can show our data on the. And in the conclusion, we had conclude that 80 mega 328 is the best microcontroller to and low cost, and sensor fabricated locally and available. It pass all the requirements, so we can use it on the field for the irrigation management. And the sensor calibration equation was found to be 1045.7 exponential power minus 0.014 into capacity of the sensor. And any kind of sensor that can be integrated with our system if it has a same pin configuration. Both the capacitive soil moisture sensor has a less value of mean absolute percent error, and the decision support our physiological algorithm can more efficient for farmer who want to grow more food in less water. And this unit price is approximately 8,000 pkr, which is low cost than market available sensor system. And my recommendation for end user is to optimize the placement and make sure your Wi-Fi network is excellent so it can work very efficiently. And for future study, I will recommend that study on the optimized placement of these sensors. And these are my comments.
Uh,
Thank you.
Thank you, Mehtab, for a nice presentation. We can take only one question if we have.
Yes, sir. Yes, sir.
Do we have question from anyone? Thank you, Mehtab. We have no question. Thank you very much.
This is Najibullah Channa from US Pakistan Center for Advanced Studies in Water. And my presentation topic is photocatalytic inhibition of PET E. coli bacteria through bismuth oxide photocatalyst. This is my presentation's content that I have to cover in my presentation. And, I start with my introduction that what is the scenario to study for the photocatalytic activities. So the what are the issues? The surface water actually contains the impurities, because the impurities come from the different sources from industrial as well as domestic wastewater, and there is no proper treatment that are performing at local and at community level. So the waste is discharged in surface water. So what's the problem? The problem is that the bacteria cannot easily treat with the simple and conventional methods. So there should be a very specific and most efficient and effective method to remove the bacteria. So the bacteria can reach at the point of use and the people get infected. So what's the problem? So we have a solutions that very different disinfectant are being used in worldwide, like a UV disinfection method, chlorine disinfection method, ozone and other methods are available. But the problem is that when we use chlorine, ozone, and other disinfectant method, they are actually generating byproducts. And byproducts actually are very carcinogenic that can cause human health problems. So this is not a very authentic solution to use to disinfect the pathogenic bacteria from drinking water sources. So I think there should be a problem to that because they are generating a carcinogenic byproducts. Why we are moving toward the photocatalysis technique, what photocatalysis method? Because it has efficiency. It can work easily. There is no any byproduct it generate, because there's, and like an ozone, chlorine, there's few byproducts that can generate, but photocatalysis process does not generate byproduct. And why it is efficient for the bacterial disinfection? Because photocatalyst has a different activity to effect on the bacteria. Some photocatalyst effect on the DNA of the bacteria. Some photocatalyst effect on the cell wall and cell membrane. So every photocatalytic material have the different ability to effect on the bacteria. So what's the problem? So the pathogenic bacteria easily reach on the point of use, and this is very dangerous situations when we use that water. So presence of bacteria in pathogenic bacteria in water sources, pathogenic bacteria reach at the point of use, especially for the remote areas. The people consume water easily at the point of use. There is no proper treatment. So our study is actually the disinfection and inhibition mechanism study, and develop the protocol for the bacterial analysis, and would be more practical information for use of these photocatalysts. So first of all, we have synthesized prepared some photocatalytic material that is based on the bismuth oxide, and that is easily available, cheap, easy to process, and easy to synthesize. First, we have observed and we have done that. We have checked that photocatalytic material is working properly or not. There is one basic test to conduct for the photocatalytic material is dye degradation. When we degrade dye and dye is degraded, it means the photocatalytic is working in the visible light. Then we move toward the our analysis that how the photocatalytic material is working against the specific bacteria. So we have used two type of bacteria, E. coli and Staph aureus, because E. coli is generally presence in the water environment, and Staph aureus is generally actually infectious bacteria that available that present in the water and also on hospital waste as well. So we have used a different methodology. We have used a cultured and liquid methodology. With the help of this test, we have actually find through the active bacterial test. So we have just take a petri plates. We have just placed a powder that is around 10 milligram, and after overnight growth, we have checked that there is zone of inhibition or not. This is actually a basic test to check the antibacterial activity of the any particle. The second thing that we have covered that the through fluorescence microscopy that we can observe that how the bacteria can be dead and live with the different times and how the material is effective and efficient. So first we have to characterize the prepared photocatalyst material, that is the material that can be synthesized or could synthesize is okay for further characterization or not. So we have conducted the different photocatalytic characterization like UV. From UV, that is the basic things that we have need for band gap. Higher the band gap, lower the efficiency of material. So here we have found a good band gap for the photocatalytic material. And this is the XRD pattern. Why we go for the XRD? XRD actually tells that the material that we have synthesized is which structure it has. So we have synthesized alpha beta, it's a mixture of particles, and it has orthorhombic crystalline structure. This is actually same images that shows that the particles are formation are unique and uniform or not. So we from same analysis we have observed that the particles are unique and uniform. It has a proper structure. So this is the photocatalytic test that you can see that the degradation curve from control to the 120 minutes. It means that the dye is degraded, the dye is removable from the water within 120 minutes. This is the basic antibacterial test that we have checked. The particle is working against the bacteria or not. Then we move through the fluorescence microscopy. All the microscopy results are promising that these bacteria can inhibit and disinfect the pathogenic E. coli from 15 minutes and 4 minutes. Actually, green colors showing the live bacteria and dead bacteria is actually showing the red color. So with the help of time, when we apply a dose, so at 4 hours, all the bacteria is removed. The concentration of bacteria initially is log 8. This is the bismuth oxide against Staph aureus that we have seen that all the bacteria is killed around 4 hours. So our study is actually uh, provides a facility to disinfect the bacteria and provide a scenario to design some processes that can be used with the help of photocatalytic processes. And it is environmental friendly. There is no any other byproducts formed. It's reactive because it has ability to generate reactive oxygen species, and these species are responsible for degradation and disinfection of bacteria because these specially directly affect on the bacterial cell membrane. Has lower band gap, higher lower the band gap, higher the generation of reactive oxygen species. In bismuth oxide, it has a lower band gap and good. These particles are inhibiting and disinfecting both bacteria, um, and this research reports a successful application for the use of bismuth oxide particles for the different pathogenic bacteria and drinking water system. So there are some recommendations that synthesized particle can be checked against the pathogenic bacteria and antibiotic resistance genes, and also a bacteria, because these bacteria cannot remove with the conventional treatment methods, and it has some special kind of treatment, and it cannot remove easily from other treatment as well, because and from photocatalytic it has the ability to disinfect with the different kind of bacteria. Bismuth-based protocols prepare disinfectant pathogen bacteria and also in a real water system um, protocols. The main thing is that the missing in the research area worldwide is protocol. There is no any protocol developed for photocatalytic material, that how can we use photocatalytic material for the disinfectant bacteria. So we have developed the protocol. The second thing is that at the point of use, there may be some design for the filters with integrated with the photocatalytic material that can be useful for the disinfection processes. And the second thing and last thing is that bacterial cell. The most important thing, we have to study that how the photocatalytic material is damaging the bacterial cell. Thank you.
Thank you, Najib Saab, for finishing your presentation in time. Do we have any question from any of the participant? जुनेद साहब, मेरा क्वेश्चन आपसे ये है कि आपने इस टेक्निक में क्या वायरस रिमूवर को भी चेक किया या सिर्फ आपने बैक्टीरिया को ही चेक किया है?
Sir, actually, we have just checked the bacteria. We have targeted the two bacteria, and now we are moving towards the virus effectiveness. So because we have developed one protocol to disinfect the bacteria. Now we are moving toward the developing one protocol for virus that are commonly found in water environment.
Thank you very much, Najib Saab, for an excellent presentation. Thank you very much. So next presenter is Ms. Hina Ishaq for her presentation on monitoring wastewater quality of integrated constructed wetland. Ms. Hina Ishaq.
Yes, sir, I'm here.
Okay, please share your presentation.
Bismillahirrahmanirrahim. Assalamu alaikum. My name is Hina Ishaq and I'm the student of Dr. Imran Hashmi. And today I'm here to present my research work entitled as Wastewater Monitoring of Integrated Constructed Wetland. The presentation will proceed in the sequence as displayed here. Moving towards introduction, first of all, as the student of NAST, the mission is to develop NAST as a comprehensive research-led university with a focus on technology, innovation, entrepreneurship. NAST, it is ranked among top 500 world universities and top 120 Asian universities. Okay, as we are talking about the wastewater, the situation package to cope with wastewater. So from introduction, water, it is an essential resource for life which greatly influences our public and environmental health. Global freshwater source, it is at risk, and majority of the problem in the 21st century today, we are facing the related to water quality, water quantity issue. As you can see the use of 50 to 100 gallons of wastewater we are using every day. So unsustainable use of freshwater sources, urbanization, increase of population, and the trend in industrial revolution have led to environmental degradation, especially by the release of partially treated or untreated wastewater into aquatic system. Therefore, Pakistan is a water-stressed country due to deterioration and exploitation of water resources. Thus, the treatment of wastewater is a basic component in a community to protect the health and environment of communities. Talking about the situation in Pakistan, per capita water availability in Pakistan at the time of independence was 5,600 cubic meter, which has been decreased by over 406%, 5,620 cubic meter in 1951 to 1038 cubic meter in 2010. And if the status continue, expected drop to an alarming level of 575 cubic feet in 2050, marking a transition from a water-stressed to water-scarce country. Developing countries, they are facing serious water issues due to poor monitoring and implementation of NEQs for wastewater discharge. The wastewater treatment process is like there are many different ways of wastewater treatment, but as we are talking about only NUST, so in NUST we have two ways, that is biomechanical and biological. In biomechanical we have MBR, that is membrane bioreactor plant. In biological it includes integrated constructed wetland, which is my research domain and the topic in which I will be focusing about. So integrated constructed wetland is defined as it is an ingenious system designed to maximize the removal of wastewater contaminants. Now, the types of constructed wetland, there are surface flow wetland and subsurface flow wetland. Surface flow wetland is at water level, it is above the ground surface. Vegetation is rooted and emerges above the water surface. Water flow is primarily above ground. In subsurface flow wetland, water level is below ground. Water flow is through a sand or gravel bed, and the root penetrates to the bottom of the bed. And when we combine the surface flow and the subsurface flow wetland, there's a third type of wetland, that is hybrid constructed wetland. Characteristic of integrated constructed wetland includes advantages. It says that it is relatively inexpensive to construct, operate, easy to maintain, effective, reliable, and ecological sound wastewater treatment, aesthetically pleasing, and provide habitat for wildlife and human environment. The cons, that it says that it may require larger land area, it can expose the odor of the waste stream, and it can be act as breeding ground for mosquitoes and other diseases. Some of the related work done at my department, that is IESC, that is concerned in 2019. The study was microbial characterization in water quality assessment integrated constructed wetland. The finding was that helminths eggs were higher in the month of October, November, and March. It shows decreased prevalence with decrease in temperature. So, but in 2019, the study was performance evaluation of constructed wetland removal of helminth parasite. The finding was the 100% removal of helminth egg in the effluent of wetland were observed, and the highest uptake of trace matter was observed when typhoid defoliator has higher biomass and efficient root system. Hochbach then believed in 2017, the study was impact of meteorological condition on the water quality of wastewater treatment system. The finding was that meteorological condition shows significant correlation with pollutant removal efficiency, and the ambient temperature shows positive correlation with dissolved oxygen and total carbon, while negative correlation with pH, turbidity, AC, COD, BOD, and TSS. At Shakil in 2017, the study was performance evaluation of constructed wetland NUST. The finding was average removal efficiency of constructed wetland. The EC was 30.6%. Turbidity shows 74.9%, TGS 30.7%. The objective of study is evaluating the performance efficiency of integrated constructed wetland through physical chemical parameter analysis. The methodology which will be focused, which I have followed at the present study, it was conducted at NUST Ashwell campus, Islamabad, for the treatment of wastewater from residential apartment, academic blocks, schools, institutes, and hostels. The layout of wetland system, it leads towards the sedimentation tank, then to a constructed wetland comprising of 8 compartments where wastewater quality is improved by remediation. The quality of effluent from the constructed wetland is further improved by use of filtration technique, that's filtration, irrigating, cropping for land treatment, effluent reuse. Specification of integrated constructed wetland, like it is as flash. These are some of the pictures: wetland before plantation and wetlands after plantation. Physical chemical parameters in the study at onset analysis and laboratory analysis of the study, they are as flash. Okay, results and discussion. Standard for wastewater discharge and agricultural reuse are given table. Although Pakistan does not have a reuse standard for wastewater, therefore we use International Agricultural Reuse Standard of US EPA for comparison. So first of all, the pH. pH, it plays an important role in productivity of pond as it affects many chemical and biological processes. The pH of sampling points were found to be alkaline throughout the study, that is ideal for vast diversity of microbes, and it hampered microbial degradation processes. However, pH effluent values range within wastewater discharge and agricultural reuse standard. Temperature. Temperature is a physical factor that alters the quality of water and considered as an important parameter in functioning of the aquatic system. Temperature in integrated constructed wetland is influenced by presence of vegetation, season, time of the day, and total dissolved solids present in wastewater. Dissolved oxygen improve as water passed through treatment system. In graph, it shows that dissolved oxygen was in the range of 3.5 to 4 milligram per liter, which may be due to atmospheric oxygen, photosynthesis, respiration, decomposition, higher organic matter. Electrical conductivity as an indicator of the total concentration of dissolved ion is a valuable tool in assessing the water quality. The graph shows slight decrease in conductivity level, which is maybe due to decrease in concentration of TDS and the conversion of nitrate nitrogen to diatomic molecule nitrogen as the concentration of charged ion decreases. Turbidity. Turbidity in water it is caused by suspended colloidal matter such as clay, silt, fine organic, inorganic matter, and plankton and other microscopic organisms. The graph shows high turbidity in point 4 due to suspension of small particles attached on roots and other plant debris, while minimum value was observed in collection tank. Total dissolved solids are the measure of the combined content of all inorganic and organic substances in water. Passed through a 2-micron filter, high TTS in water body cause eutrophication, which finally leads to water pollution. The graph shows low concentration of dissolved solids in collection tank, which is maybe attributed to less solid deposition due to decrease of water speed as it passes different ponds. TSS in TSS again the point 4 shows rise in suspended solid, which may be due to increase in organic matter because of death and decay of plants. Segroy et al. In 2018, it reported that high TSS and turbidity value presumably related to the decay of plant biomass, which caused the release of solids and organic compounds. Nitrates are contributing to discharge of sewage, industrial waste, and runoff fertilizer, decay vegetable, and animal matter from agricultural land. Nitrate production integrated constructive wetland would enhanced by facultative microbes present in it. Low nitrate nitrogen concentration recorded at the integrated constructive wetland outlet. It is maybe due to denitrification, where nitrate is converted into diatomic molecular nitrogen, deposition of nitrate in sediments at the integrated constructive wetland bottom, and uptake of plants. Nitrate, it varies constantly, where it shows no significantly trend. TKN, again, it is a combination of organic nitrogen and ammonium nitrogen. It varies to different forms. High organic nitrogen in wastewater it causes increase in TKN values, which may be because of its conversion into ammonium ion, while consistent decrease in values of waste pond and minimum concentration was detected in final effluent of collection pond, maybe due to different substrate, existence of aerobic and anaerobic condition. Again, it was further satisfied with Said and Sant in 2012. It is reported alkaline pH and oxygen limit condition were favorable for promoting the growth of ammonium nitrogen oxidizers, allowing nitrite reduction over nitrate. Okay. The phosphate removal efficiency is mainly due to absorption in very minute amount removed from plant uptake and microbial degradation. Phosphate removal efficiency shows consistent decrease in each sampling point and minimum value record at collection tank, which is maybe due to plant's uptake of the phosphate, or some of it is deposited in the wetland bottom with sediment and adsorption. COD, the chemical oxygen demand, it is an important parameter for measuring organic pollution in water and is used in some states as a national standard to examine the aqueous organic pollution. Wetland detention, decomposing microorganisms, and temperature in a water body, it contributes to low COD concentration. Observant outlet may be attributed to biodegradation of the organic matter by microbial bacteria in the wetland, trapping of particular organic matter by wetland plants. Moving towards conclusion, performance evaluation indicated constructive wetland removal efficiency. Overall physical parameter removal efficiency was up to 89% for total suspended solids, 95% for total dissolved solids, 85.02% for COD, 61% for nitrite, 98% for nitrate, 69% for TK, 80% for phosphate. Further, we can say that this study depicts an integrated constructive wetland. They serve as an environmentally friendly and an equally efficient technology, and it has a considerable protection for the removal of pollutant from wastewater. Some of the recommendations include if the effect on soil structure is microbiota by irrigating to treat water can be studied. And another recommendation that we can use the alternative plants to increase the performance efficiency of integrated constructed wetland. These are the acknowledgements, some of the references. Thank you.
Thank you, Hina, so much for a very nice presentation. Do we have question from Hina?
Sir, I want to ask something. Yeah.
Okay. Please introduce yourself first.
I'm Junaid Kori from University of Mehran University of Engineering and Technology. So my question is, your graphs are showing that in inlet water, the TDS levels and nitrate, phosphate levels are very low, and COD level is very low. Is it that the inlet water was the wastewater or something?
Yes, inlet that is the wastewater which is coming from different like residential apartment of Nats University, different departments, and the housing society in the Nats University.
So is it a gray water or something? Because these levels are very low. I guess in the wastewater, Usually we observe very much COD levels, TDS level, and all other parameters.
Yes, because some of the wastewater it is treated by this, that is integrated conductivity, and some of it is treated by MPR. So this is basically a wastewater.
Okay, thank you.
Thank you, Hina. Thank you very much. Now we move to next presenter. I request Mr. Noman Ali for his presentation on identification of antibiotic resistant bacteria in hospital sink and sink traps of Jamshoro, Pakistan. Mr. Noman Ali.
Bismillahirrahmanirrahim. My research topic is about the identification of antibiotic resistant bacteria in optical synthesis of Jamshoro, under the supervision of Dr. Jamil Ahmed from the Hospital W. News. These are the contents of my presentation.
नोमान साहब आपकी आवाज जो है ना उसमें इको आ रहा है आपका या तो स्पीकर भी ऑन है वो दो वॉइस हमें रिसीव हो रही हैं आप अपने स्पीकर को काइंडली ऑफ कर दें और माइक में बोलें
हेलो सर अभी आवाज है
हाँ जी आप बेहतर है प्लीज गो अहेड
हेलो
जी नोमान साहब गो अहेड
Introduction. Antibiotics are characterized as one of the most useful drugs group to manage bacterial infections. As we know that once antibiotics were considered as one of the most effective drugs for the treatment of bacterial diseases such as typhoid, pneumonia, tuberculosis, and many other diseases. But past few decades, we've seen that there is an increasing issue of resistance. And due to this, antibiotic resistance has been perceived as a major health threat to the public. Hand washing sinks are a major reservoir of antibiotic resistant bacteria in hospitals, which indicates an alarming rise in hospital outbreaks. Hand washing sinks played a role as a reservoir for some of the most concerned antibiotic resistant bacteria, that is carbapenem producing enterobacterium, which we have evidence, but it is not well understood that how it can transfer to the hospital-based patients. And many recent ongoing research shows that these three brands become colonies of highly rated antibiotic resistant bacteria, which resulted in hospital-acquired infections. Gram-negative bacteria, particularly those with carbapenem resistance, represent some of the most concerned bacteria with drug resistance because they leave only a very few treatment options for infected patients. So the objectives of this study is to identify the antibiotic resistant bacteria through the sink sampling in the hospitals of Jamshoro, and the other part is the assessment of wash facilities in hospitals through questionnaire survey. Methodology. This study was conducted in 40 hospitals of Jamshoro district of Sindh, Pakistan. This study comprises of two parts: the wash facilities assessment, which followed by the optical sampling for antibiotic resistance. The assessment of wash facilities through questionnaire survey, which includes medical sections, water, sanitation, hygiene, and healthcare waste management. The samples which were collected from those facilities were analyzed for antibiotic resistance by using antibiotic sensitivity method in the water quality lab at US Pakistan Center, New Jamshoro. Then the isolation of those pathogenic bacteria on the specified area. And then we determine the antibiotic resistant bacteria through the disk diffusion method. And after the incubation period of 37 hours, where the room temperature, the antibiotic injection zone diameters were measured. And the analysis of the results was done on SPSS, and then these results were compiled in the form of graphs and charts to show the final results. The study, as we know that the study comprises of two parts: assessment of water capacity and the optical film sampling for the antibiotic resistant bacteria. The results revealed that the all tested antibiotics, we tested 4 antibiotics, which are Isotherm Studies and Absorption and Sectoral. And these all antibiotics shows resistance to the 84.62% of isolates of gram-negative bacterial growth from those 40 samples. And while 7.69% of isolates displayed resistance to only 3 out of 4 antibiotics, these are Interpinum, Citricine, and Testosterone. And the remaining 7.69% isolates displayed resistance to only 2 antibiotics, these are Interpinum and Testosterone. And this graph, it shows basically the E. coli response to all tested antibiotics. As we already know that we use 4 antibiotics: ertapenem, cetirizine, aztreonam, and ciprofloxacin. So the results reveal that the 40% of ertapenem shows resistance to the all acrylates, and the 70% of acrylates shows resistance to cetirizine, and 60% of acrylates shows the resistance to the aztreonam, while no any isolates show any resistance to the antibiotic ciprofloxacin. And all the isolates of ciprofloxacin show the susceptibility. And same response for the fecal coliform, which tested for all antibiotics, where we found that the 26.6% isolates of fecal coliform showed resistance to ertapenem, and 86.66 shows resistance to cetirizine, while 60% shows aztreonam resistance, and 26.6 isolates shows resistance to the ciprofloxacin antibiotic. And then we do the Pearson correlation to show the correlation between the all tested antibiotics, and from the Pearson correlation we find that the antibiotic ertapenem shows very weak positive correlation with cetirizine, but it is not statistically significant with the cetirizine. And ertapenem shows negative correlation with both aztreonam and ciprofloxacin antibiotics. And both ertapenem for both these antibiotics aztreonam and ciprofloxacin, these both are not statistically significant with ertapenem, as we know that the p-value is greater than 0.05. And the for cetirizine, we see that it is moderate, medium positive correlation with aztreonam antibiotic and the ciprofloxacin. And both antibiotics are not statistically significant with cetirizine, while aztreonam is very weak positive correlation with the aztreonam, and it is also not statistically significant. Conclusion: based on the current results of the study, that we found that cetirizine and aztreonam were found to be more resistant to the E. coli as compared to the ertapenem and ciprofloxacin. And the water sanitation and hygiene sources in majority of hospitals were below the standards set by the WHO World Health Organization. Based on the results, it can be concluded that there is a very dire need to improve the water facilities in the healthcare system. References, these are the references.
Thank you, Noman Saab, for completing your presentation on time. Do we have any question for Noman? Do we have any question for Noman? No question. Thank you very much, Noman, for your presentation. We move to next presenter. I request Ms. Sakina Ahmdani for her presentation on performance evaluation of constructed wetland to treat the wastewater generated at US Peace Cause building. Ms. Sakina Ahmdani.
Bismillahirrahmanirrahim. First, I introduce myself. I am Sakina Amdani from US Pakistan Center for Advanced Study. I'm working under the supervision of Dr. Rasul Baksh Mahal and co-supervisor Dr. Naveed Ahmad Kambrani. My research topic is performance evaluation of constructed wetland to treat the wastewater generated at US Picas W building. These are the outline of my presentation. I start from introductions. As we know, in the life, the water is one of the most essential component. On the other hand, it has qualitative flaws and quantitative limitations. At the global scale, the availability of fresh water is deficient to prolong the rapid growing population. The global water use is projecting to increase up to 55% by 2050. 88% of the water which is used for municipal is discharged as wastewater without any treatment. Therefore, it causes the interest of the people to recycle the wastewater. There are so many options to treat the wastewater, like convention units, which involve high capital and high capital cost and high energy consumption, because they produce sludge, which require not only further treatment but also proper disposal. Constructed wetland are the green treatment options to traditional treatment. Constructed wetlands require no chemicals for the treatment of the wastewater, so it is also known as eco-friendly technology. These are the different type of constructed wetlands according to the flow and different type of plants which are harvested in the wetland for the removal of the contamination. Now here is what is the problem. The wastewater generated from US Picas W building was treated by constructed wetland treatment plant. But after the construction, performance evaluation, monitoring and maintenance were not carried out. The current study will evaluate the performance efficiency of this whole treatment system so that we can recycle the treated water for different purposes in the center. The same method will be recommended for the treatment of wastewater for the other institute of the Pakistan. These are literature review which I have studies, and these are the findings results which are related to my research. They are the removal efficiency of COD, total nitrogen, and phosphorus and ammonium nitrogen. These are the research question and research objective of my study. Scope of the work: this study would provide the opportunity to manage the quality of wastewater produced from existing constructed wetland. The success story of this treatment unit would be recommended to the government authority to replicate throughout the country for the treatment wastewater generated from the educational institute. These are different removal mechanisms which occur in the constructed wetland for the pollutant removal from the water. This is a conceptual framework of my whole study, like literature review, introduction, objective, data collection, finding, recommendation, and conclusion. These are sampling points. The wastewater samples were collected from manhole, septic tank, from inlet and outlet of the bed in the pre-washed polyethylene bottles, and then directly transferred to the water quality laboratory of US Picas W for analysis. And the standard methods are followed to measure these parameters to evaluate the efficiency of the wetland. That is bacterial analysis. We collect the biofilm sample from the gravel media and then extract the biofilm from that gravel media. After that, the basic culturing through spread techniques. Different agars are used for selecting pathogens. This is media preparation for the bacterial analysis. After media preparation, we culture through the plate technique and prepare the sample and spread out the petri dishes. And then we incubate these samples for 24 hours at 37 degrees centigrade. After that, then the colonies are formed on the petri dish, and at the end, these colonies were enumerated by counting colony farming units. These are the characteristics and design feature of my whole treatment plant, like septic tank, wetland bed, and disinfection tank. System wetland operational conditions. The system were operated under natural ambient conditions and open to the sky throughout the study period. Atmospheric pressure was considered at the local pressure at sea level. The temperature was 35 at summer season and 10 degrees centigrade in the winter. The influent flow rate was 7.86 meter cube per day. Hydraulic loading rate was 0.7 meter cube per day, and hydraulic treatment time is 0.5 day to 1.1 day. These are characteristics of the wastewater. It influent. The average pH was 7, and the BOD and average BOD is 177 milligram per liter. COD is 422 milligram per liter. TS is 227. These values are average, and total nitrogen is 55.7 milligram per liter. After the pre-treatment, after from the main hole, the water, the wastewater come to the septic tank. In the septic tank, where it gets pre-treatment of the water, the sedimentation of occur at the septic tank, and these are the average values at the septic tank. Effluent wastewater characteristics: the average, all the treated water samples meet SEQs for disposal into the land. In this table, the findings were that the average effluent BOD values were below 60 milligram per liter, meeting the SEQs for inland water standard, which is 80 milligram per liter. Average effluent COD values are below from 150 milligram per liter, and the average TSS values were found within the SEQs, which is about 200 milligram per liters. Wetland system performance. These are overall performance of this wetland. Removal of biochemical oxygen demand. These bar graph shows the influent characteristics of wastewater at different points, sampling points like at manhole, at septic tank, and at the bed inlet. And the line graph shows the characteristics of wastewater, characteristics of effluent wastewater. The overall removal efficiency is varies between 75 to 87%. Removal of chemical oxygen demand. The overall removal efficiency of COD varies between 60 to 83%. These bar graph shows the influent characteristics, and the line graph below shows the effluent characteristics of wastewater. Removal of total suspended solids. The removal efficiency of wetland varies between 60 to 80%. Overall, 80% removal of total suspended solids at the wetland. Removal of total nitrogen, which varies between the removal efficiency of total nitrogen in the wetland was between 60 to 75%. 75% wetland remove the total nitrogen. This is a bacteriological analysis in the inlet and outlet of the bed. The selective pathogens such as total coliform, Escherichia coli, Salmonella, and the Vibrio coli was cultured separately by spread plate technique on selective agar plate for each pathogens. And these plates were incubated for 24 hours at 37 degrees centigrade to count the valuable colonies. The sample size is 13 and the frequency is 100%. It means the concentration of E. coli and total coliform, Salmonella, Vibrio coli present in both samples, inlet and outlets. But inlet, it is
Sakina, you
in a high
have 1 minute to
quantity
conclude.
as compared to outlet. Outlet is a low quantity. Overall,
Sakina, you have 1 minute to conclude.
Yes, sir. Overall removal efficiency is 44%. Yes, sir. The wastewater before and after treatment. Conclusion: in this study, a constructed wetland treatment system was monitored for pollutant removal efficiency at US Pakistan Center for Advanced Study on Water, Iran University, Jamshoro. Even the period was short. The monitoring period was short, only 1 year. The result obtained provide a strong indication the wetland system present in the center efficiently treat the wastewater. The following conclusion I'll draw from this study: pollutant reduction in the term of COD by 83%, BOD 87%, TSS 83%, and TN by 75%. And the selected pathogens such as total coliform, Escherichia coli, Salmonella, and Vibrio coli were examined, and the removal percent of these pathogens is 44%. The recommendations, these are the following recommendations: that all components of wetland require maintenance to keep the wetland working properly, and place an effluent filter on the outer of septic tank to decrease the clogging of media. Periodically desludge the septic tank to decrease the number of solids entering the wetland bed, and they trim the plant shoots and leaves and remove dead plant debris to the system free of prevent the soil to entering the wetland bed. The wetland system at glance on the operation is the maintenance, the references I have followed. Thank you.
Thank you, Sakina. Thank you so much for a very nice presentation. Do we have any question for Ms. Sakina? Do we have any question for Ms. Sakina? No question. Thank you, Sakina. Thank you so much. So we move to next presenter. So I invite Ms. Fazila Yunus for her presentation on chromium concentration, its speciation, and geochemical behavior in ternary industry wastewater of District Kasur, Punjab, Pakistan. Do we have Ms. Fazila? Now I request Mr. Altaf Hussain Maksi for his presentation on continuous mode absorption of arsenic from aqueous solution using iron impregnated biochar. Mr. Altaf Hussain Maksi.
I'm Altaf Hussain. My research topic is continuous mode absorption of arsenic from aqueous solution using iron impregnated biochar. These are the contents. Introduction. Water is a basic necessity for the survival of everyone, but freshwater resources has been contaminated or deteriorated due to various anthropogenic activities. Arsenic is one of those contaminants which pose a serious threat to the human life, as it destroys the digestive system, nervous system, and it has the capability to be a carcinogenic element for the human. According to the UNICEF report in 2008, about 60 million people in South Asian countries were consuming arsenic contaminated water. As Ali mentioned in his research, that 7 lakh people diagnosed with various diseases caused by arsenic contamination in South Asian countries. So this is also a problem for Pakistan that must be overcome. There are several techniques that have been developed by various scientists that treat arsenic very well, but these techniques are expensive and require expertise for the operation, as well as they require the large space for their plant operation. On the other side, absorption is the cheapest process. It is light in weight. The absorbents used for the treatment of arsenic contaminated water, and it does not require any sort of sophisticated instrumentation and expertise for the running the operation. In this study, fixed bed column was fabricated from the iron impregnated modified biochar produced from the feedstock of local available biomass, that is Acacia nilotica. In Urdu, we can say bubble. These are the research objectives. An objective one is to fabricate the iron impregnated biochar and characterize it. And second objective is to determine the behavior of the absorption capacity, and absorption capacity of biochar through fixed bed column study under different conditions. These are the literature review. People who have studied the same work. In methodology was divided in 3 sections, 3 phases. In phase 1, the iron impregnated modified biochar was fabricated and the column was fabricated. In the second section, the material was characterized to check its physical and chemical properties. And in section 3, in phase 3, the absorption study was conducted. Initially, in the phase 1, the biomass was collected and prepared for the pyrolysis, where the biomass was heated at 550 degrees centigrade for 2 hours in the absence of oxygen. Then it was ground, washed, dried, and sieved and prepared for the modification, where sieved biochar was modified with iron nitrate through simple impregnation technique. In phase 2, material was characterized through scanning electron microscopy, Fourier transform, infrared spectroscopy, the spectra, zeta potential, and uh, in phase 3, the absorption study was conducted. This is the experimental diagram that shows how absorption study takes place. In this study, 1,000 milligram stock solution was used, which was diluted to appropriate concentrations. And these are the reference parameter were selected for the initial study. Here, a solution was passed with the help of a solution was passed through the column from top to the bottom with the help of peristaltic pump with a certain flow rate, where after every half hour the effluent was collected and preserved with uh, with by putting 2% of nitric acid in the sample, and it was analyzed through ICP-MS. These are the different conditions under which the efficiency of biochar was performed, detected, calculated. There with different dosages, with different flow rates and different concentrations. And finally, the groundwater study also was conducted. And these are the mathematical expressions through which the absorption capacity was conducted, and graphics was graphical representation was generated. Scanning electron microscopy that illustrates the morphological characteristics of pristine and modified biochar. In pristine biochar, we can see that there are micro and mesopores. Surface is smooth. On the other hand, we see in the modified biochar surface is rough and irregular in the shape. So it indicates that there's the attachment of iron nitrate on the surface of the biochar. It shows it determines the elemental composition through elemental analysis. Here we can see the different elements in the elemental composition in the composition of biochar. Carbon and oxygen reflect the hydrophobicity and hydrophilic nature of the biochar. In the modified biochar, we can see there is the presence of iron, which shows that the modification was successfully conducted. In Fourier transform infrared spectroscopy, detects the functional groups in the biochar, such as we can see in different stretches and bands here. There's an alcoholic group, amines, carboxylic acid, and benzene and alkanes. In zeta potential that detects the charges on the surface of biochar, and zeta potential confirmed that both are negatively charged. Here in the results, it's objective two. In objective two, the breakthrough curves were generated to determine the behavior of the adsorption. We can see in this section, this is the breakthrough curve graph, where it is yes. Here we have to determine its a saturation point. So this is the saturation point where 90% of the column is consumed, where in the final concentration becomes equal to initial concentration, and with respect to time. So we have to define the saturation time, how much uh, how the study was conducted, and how the behavior of the absorption is determined. So we can see here in bed depth study that uh, with increment in bed depth, the uh, the saturation time was increased. It is because of more active binding sites in the biochar, and longer retention time, which and maximum efficiency also observed in this bed depth study. increasing bed depth, it increases the removal efficiency. On the other hand, we can see in concentration study, there is a with maximum concentration, there was a maximum removal, but saturation time was decreased. It is because of the concentration gradient. And we see the fluoride study. In fluoride study determines the relation between absorbent and interaction between absorbent and absorbate. So with increasing flow rate, there was a low interaction between the absorbent and absorbate. Due to this, with the increasing flow rates, the saturation time was decreased in the graph. Here, we also conducted a study on real water samples, groundwater samples, and efficiency of 4% efficiency was decreased because of the other elements, minerals, presence of other elements and minerals in the real water. Here, this is the we calculated the absorption capacity experimentally and through the model, and we can see that with higher concentration, the absorption capacity was high experimentally and in model both. On the other hand, we see that we did a depth study in the absorption capacity, and we found these absorption capacity in all the conditions. And this was the absorption capacity of real water. In the conclusion, although this study did not satisfy the allowable limit for drinking water prescribed by World Health Organizations, but it has capability to treat water with 90% of removal efficiency. At these parameters, with a flow rate of 3 ml per minute and concentration is concentration was 3 milligram per gram, and bed depth was at 15 centimeter, worked well with a maximum absorption capacity, and maximum removal efficiency was observed. In future recommendations, I can suggest that a study should be conducted by changing the direction of the flow from bottom to the top, and efficiency can be increased column efficiency should be observed also on the different diameter, and regeneration study should be conducted. I want to acknowledge them, and these are the references. Thank you.
Thank you very much, Altaf Saab. Do we have question for Altaf?
Yes.
Please go ahead. Do we have question? Thank you, Altaf Saab. There is no question. Thank you very much for your nice presentation. I believe we have Inza here.
Yes, sir. Assalamu alaikum everyone. I am Inza Murtaza. I am a scholar at the School of Economics at Delhi University. First of all, I would like to commend this initiative of organizing a conference on such a contentious issue of water, which is the epitome of life on this planet. It's a privilege to be part of this conference. Today my topic is population and water supply in Pakistan. This is a theoretical analysis of Pakistan's water issue. These are the brief contents of this presentation: introduction, literature review, methodology, data, results, conclusion. Starting from introduction, natural resources are pivotal for the economic development of a country. In order to develop a country, it must efficiently explore and utilize its resources. One of the most pivotal of these natural resources is water. Human demand for water is incessantly increasing due to rapid population growth. Pakistan is in danger of facing severe water scarcity. Population growth rate in Pakistan is 1.93%, which is exerting extra pressure on limited water resources. Higher population puts pressure on water resources, which can lead to severe water stress, as it was evident in Karachi last summer. As can be seen from this map, Pakistan can face extremely high water stress by 2040. For example, in 1960, per capita water availability was 5,600 cubic meter, and now it is 1,000 cubic meter. In Pakistan, most water-intensive sectors is agriculture, followed by municipal and industrial respectively. The debate on water is mainly focused on contamination aspects of the problem with a very limited sort of focus on the sustainability of existing water supply and of future projection. Very often we listen on news and social media about unavailability of safe drinking water, but we have a more severe supply shortage looming in the near future. Water availability is what matters eventually, but the developing countries like Pakistan, faced with extravagant economic circumstances, tends to overlook it and are more inclined towards addressing the exorbitant macroeconomic issues. As a result, this contentious issue is overlooked, which can be dangerous. Moving to our literature review, starting from Butler, said human demand for water is continuously growing with increasing population growth. Ahmed pushed its effort in 2007. Water conservation and water quality in Pakistan are not meeting its requirement. Pakistan is considered a water deficit country, according to Bhatti, and in Bound says government must consider this issue on a serious note and should take steps to meet water demand. Of course, there is a literature gap. There is limited literature available on water issue, with no recent studies have forecasted the relationship between population and water supply. Methodology used for projection of water supply and population is time series forecasting technique. A very simple technique is used here, avoiding fancy econometric techniques. It's easy to understand for the readers. To make a smooth process of forecasting, Microsoft Excel syntax is used here. Water withdrawal is used as a proxy for water supply, with agriculture, industry share to GDP are representing water demand in the respective sectors, and urban population represent demand for water in municipal sector. Time series data used here in water withdrawal is taken from world development indicators and aqua state. At first stage, quarterly data is converted into yearly form for best comparison of population and water supply in Pakistan. Study period is 1975 to 2043. For the result, starting from population projection, population is projected from 2018 to 2043, showing a linear upward trend, reaching almost 300 million by 2043. We don't know that what we will do with all these people. Water supply projection, water supply are also projected for the same period, but it does not have linear trend like population. Now we are moving towards sectoral analysis. For sectoral analysis, starting from agriculture sector, the comparison shows the demand for water as measured by agriculture GDP increasing rapidly and agriculture water supply remains almost stagnant. Government packages and policies for agriculture rarely mention water issue. We have an inefficient irrigation system. For industrial sectors, water availability is much better as compared to agriculture sector. Although industrial sector less water intensive as compared to other sectors, but still demand is increasing rapidly with almost stagnant water supply. Municipal sector, for municipal sector, demand is increasing rapidly owing to urbanization, whereas supply remains almost stagnant. Conclusion, it's hard to meet the upcoming challenges of high water demand. There is dire need of comprehensive strategy to control this terrible situation in future. By comparing water demand and supply, the study concludes that there are no significant changes in water supply as compared to water demand. Policy recommendations are awareness campaigns should be launched at all levels. Adoption of latest water conservation technologies should also be considered at local level. Water recycling is another potential area. Most of the developed countries adopted water recycling and they pushed their economy back from water stress. Now in Pakistan, it has received little official attention and research limitation. Different scenarios can be incorporated in future studies on this topic. And there are data limitations as this study have to use proxies for water supply and water demand. So there is space for future research on this topic. Thank you very much. That's all from my side. I would be very happy to answer your question if you have any.
Thank you very much, Inza. Do we have any question for Miss Enza? Do we have any question? Thank you so much, Enza. Thank you very much. Uh, I believe I am finished with my list I have been provided. So may I request Abdul Mannan, who wants to give presentation?
Thank you, sir. Thank you for giving me opportunity to present my research work in your conference. I am Abdul Imran from Mehran University of Engineering Technology from Environmental Department. Today I am here presenting on presentation on fixed bed column study for water defloration through bioabsorbent material. Okay, these are my contents of presentation. Let me start with introduction. As we know, water is essential part of human life. Life cannot be survived on the planet without water. And according to Sustainable Development Goal, every human has a right to access safe and affordable drinking water. But our water is going to contaminate through natural activity and human activity. This contamination of water has direct impact on education, health, growth, and economy. There are many contaminants available in drinking water, but among them, fluoride is one of the most highlighted contaminants. If its concentration is less than 1.5 milligram per liter, it is beneficial for human growth in terms of dental health, proper growth, and bone health. If its concentration increasing from 1.5 milligram per liter, it has adverse impact on human health in terms of kidney disease, skeletal disease, and dental disease. uh, in Pakistan, there are many areas which have been declared as a hotspot for high concentration of fluoride in drinking water and surface water, such as Lahore 19.7 milligram per liter, Quetta has 24.48 milligram per liter, Karachi has 2.77 milligram per liter, and Thar has 0.06 to 44.4 milligram per liter. And this water has adverse impact on human health. You can see over in the pictures. And the sources of fluoride are, there are two type of sources available for fluoride extraction in the drinking water. One is natural sources and other one is anthropogenic sources. In natural sources, there are volcanic eruption and leaching of uh, geochemical reaction minerals from rocks to groundwater. And anthropogenic sources are basically industrial waste and mining and the brick tea infusions. On the basis of problem statement, I have developed two objectives. One is to fabricate bioadsorbent for fluoride removal. And second objective is to investigate the fluoride removal efficiency of bioadsorbent in fixed bed column. On the basis of my objective, I have done literature review. And the summary of literature review is that there are many techniques available in the market for fluoride for treatment of water, like electrocoagulation and flocculation, nanofiltration, waste carbon slurry, anion exchange, reverse osmosis, adsorption. Among them, adsorption is one of the most highlighted technique which have been practiced more because it is easy to handle, easy to operate, and inexpensive process. But in adsorption process, adsorbent is also facing different issues like poor removal efficiency, high processing cost, availability of raw material, production of toxic sludge, poor regeneration, difficulty of dispose of. And according to my literature review, I have found that neem seed has a benefit in terms of efficiency, low processing cost, local available material, least production of toxic sludge, regeneration, and easy to dispose of. On the basis of my material and my objectives, I have developed methodology. First I have collected raw material that is neem seed from the market. This collected raw material further process for material preparation. In first process, I have done physical activation of neem seed through pyrolysis process at 350 degrees Celsius temperature for 3.5 hours. After physical activation, I have done chemical modification through ferric chloride and again and sieved to 1 to 2 mm. This sieved material filled into the column where synthetic water was coming from the top of the column and collected from the bottom of the column. This effluent was analyzed by spectrophotometer, and I have selected 2 points for the characterization, that is before chemical modification and after chemical modification. And the characterization techniques are SEM, EDX, and FTIR. SEM for surface morphology, EDX for material composition, and FTIR for functional group. And further more, I have designed my study on the variable parameters, on the three variable parameters: flow rate 357 ml per minute, concentration 5, 10, 15 milligram per liter, and bed depth was 5, 10, and 15 centimeter. And I have select column with the diameter of 2.5 centimeter and height was 20 centimeter. Now now there are many models available in the literature for the determination of column efficiency, but among them, Thomas model is one of the most accurate model for downward flow column. These are the three materials and their preparation method: neem seed and their method, biochar and modified biochar, their method, and the composition which I have mixed. Now I'm moving toward the results. Here you can see the SEM results at magnification of 1kx, and this is the SEM results at 5kx before modification and after modification. Before modification, you can see that surface area is very clean, and after modification, you can see the white spot. These white spots are basically the iron deposition on the surface of biochar. Now I'm moving toward the EDX of biochar. EDX, where you can see the iron has iron is 1.03, and after modification, iron becomes 9.7. Its composition on the surface of biochar. In FTR, you can see the OH group which are not favorable for defluoridation technique, and after modification, OH group are removed and these OH group are converted in CH groups. CH groups are favorable for defluoridation. This is a calculation for the standard curve where I have developed a stock solution, working solution, and 5 different sample solution by using the dilution equation C1V1 and C2V2. And on the basis of my solution, I have developed this curve, standard curve. Remaining calculation I have done through with the reference of my this standard curve, who has efficiency of 0.999. Now I am moving toward now I'm moving toward my breakthrough curve. This is breakthrough curve of variable concentration. You can see in this graph, I have kept all the parameters constant and change only concentration: 5 milligram per liter, 10 milligram per liter, and 15 milligram per liter. Blue color showing 5 milligram per liter, orange color showing 10 milligram per liter, gray color showing 15 milligram per liter. And in this graph, you can see I have found breakthrough time and exhaust time, that is showing below of the table. Like for blue curve with the concentration of 5 milligram per liter showing breakthrough time of 250, and exhaust time is 560 minutes. And for orange curve with the concentration of 10 milligram per liter showing breakthrough time 30 minutes and exhaust time 390. And for gray curve with the concentration of 15 milligram per liter showing breakthrough time 15 minutes and exhaust time 270 minutes. Similarly, in second graph, again I have kept all the parameters constant except flow rate. Again, you can see the breakthrough time and exhaust time against each curve. Similarly, in third graph, I have kept all the parameters constant except bed depth. Again, you can see the breakthrough time and exhaust time against each curve. Now I am moving toward model calculation. In this table, you can see I have performed test 2, 3, and 4 at variable concentration, test 5, 6, 7 at variable flow rate, and test 5, 8, 9, and 10 at variable bed depth. And in bottom row, you can see the adsorption capacity of column, which is determined through Thomas model. And this adsorption capacity higher concentration, low flow rate, and low bed depth. Now moving toward uh, conclusion. Through my research, I have developed inexpensive sustainable development technique for the in this present research. Uh, Neem seed biomass is an indigenous material which has a capability for the removal of fluoride from the synthetic water. Result obtained from this study indicate that column with the optimum bed thickness, lowest flow rate, and highest fluoride concentration showing best column performance. Its efficiency increased by the impregnation of iron chloride at 200 rpm for 24 hours. The iron impregnate biochar showed physical and chemical absorptions. Now these are the recommendation for further study, where you can do uh, regeneration study, column efficiency study, competitive iron study, and waste product study. And I want to acknowledge Uzma Imran, Dr. Jennifer Veda's mentor at USA, and Dr. Jeffrey and Miss Uneza. These are
Thank
my
you, Manan. Thank you, Manan, for a very impressive presentation. Really impressive presentation. Yes, we have one question from Shafiq Rahman.
Assalamu alaikum, Manan Sahab. I have one question regarding the characterization of the adsorbent. Could you please tell me where did you perform this characterization of the adsorbent?
Sir, I have performed SEM in University of Utah, USA, and remaining test I have performed from Sin University and ComSet Islamabad.
Thank you
Hello?
very much. Thank you very much, Manan. Thank you so much.
Okay, sir.